Hey guys, how you doing? This is Coach Scott. Let's go to our next little lesson. Hybridization theory, and I'll be honest, this is high level. Okay? And again, a lot of things, and we're just going to introduce this. But why do things occur in these molecules like they do? Let's think about it. Carbon. All right, if you were to draw the electron orbital diagrams, carbon, it's got 6 electrons, right? We draw the 1s like so, right? We draw the 1s like so. And it'd be like that. You'd have 2 electrons. Let's put some arrows on there so they look right. Then you have an electron there and 2 electrons there in the 2s, so we're in the second energy level. And then you'd have electrons in the p's. You'd have 2 electrons in the p's. According to that theory, carbon should only be able to form 2 bonds, covalent bonds. It should only be able to share 2 electrons. But we know, we've measured and studied it. Carbon will form 4 bonds, not 2. So we got carbon dioxide. There's 4 bonds there. Okay? Shouldn't be. So as we often do as scientists, is we looked at the theory and we said, well, let's change it to the known facts. So the theory is this, the hybridization theory, is that the s's and the p orbitals, they're so close together that carbon in a lot of elements, and this is where we get expanded octets, will hybridize those sp orbitals, and they'll make a unique orbit, all right, called the sp orbital. And there's 4 different, there's s, okay, s, well, let's go back right there. Sorry, guys. You've got s's, you got 1s, 3 p's for 4 total orbitals. So this would be sp, this would be an sp, sp, sp. Now, this explains how carbon can have 4 bonds. So again, we look at the known evidence and figure it out and try to explain what we see. That's what we do in science. So, to figure out if you've got hybridization, we've got to look at that first Vesper number. This is going to tell us how many electron domain are going to need to be hybridized. So if I look at methane, all right, it's got 4 domains, right? Darn it. Well, now, doggies. That's okay. We'll figure it out. It's got 4 electron domains, 4 bonded. So carbon is going to require 4 orbitals, all right? So what it's going to do is it's going to hybridize, the theory says, the s orbital and all 3 p orbitals, and that's going to give us the sp3, 4 s3p hybrid orbitals. Okay? Now, if I look at ammonia, let's find out what that one is. If I look there, I've got 4 domains, so ammonia also hybridizes the s and p3, s and the 3p orbitals into sp3 orbitals. All right. Now, let's look at carbon dioxide. There's 2 domains, 2 electron domains, those 2 double bonds. So the first Vesper number is going to be 2. So it doesn't need all 4 hybrid orbitals. So what they're going to hybridize would be just 1s and 1p orbital. So these would be what we would call the sp orbital, hybrid orbital. Now the other 2p orbitals are going to move around the bonds, all right? Going to move around and they're not going to be part of the hybridization. All right. And those are what we are using to form the double bonds. And we call the double bond, the second bond, a pi bond. That's all we really need to worry about right now. Okay. So we got to think which of the following would require a sp2 hybridization. So we need 3 hybrid orbitals. Well, we're looking for something with 3 electron domains. I'm believing that's going to be BF. Let's see, it's going to be a BF3 because it's got 2 or 3 electron domains. It's got a Vesper number of 3. What would be the hybridization found on oxygen and oxygen difluoride? It's going to have, you're going to have 2 lone pair. Let's see, I may have to draw that out. So oxygen, F2, that's going to be 6, 7 plus 14. You're going to have 20 electron domains, or 20 valence electrons. Let's go ahead and draw it out, like so. I'm going to put, there's 2, 4, 6, 8, 2, 4, 6, 8, 10, 20, 2, 4, 2, 4, 6, 8, 10, 12, 14, 16. So it's going to have 4 domains. So I believe that's going to be sp3. I'm right. So that's going to pretty much tell us what we need to know about hybridization. And for those that want to have some more understanding of where these pi bonds are and how they're formed, I've got some cool videos that I'm going to tag on to a OneNote that you can link to. And some of them are about 20-30 minutes, but it's really sort of cool. So no, that's why things work, because some of you might be thinking, well, why aren't we having 4 bonds when there's only 2 free p orbitals? That's how we do it. And again, we're not going to go much into depth on it. Some of you will be taking higher level chemistry courses in your career. And I just wanted to have a brief introduction to the hybrid orbital theory. In AP chemistry, you need to know about SP, SP2, 1, 2. Pretty much what we just did. If you knew that, you could figure that out, you're golden. Okay, guys, this is Coach Scott saying have a great evening, and I'll see you on the flip side. Bye.